log into our AI for financial service application, or you can create your own application. In this case, we will log in as a developer user, or you can also create your own user. You can access RAG AI agent from the left navigation or from the home page. Click on the search in knowledge base tab. Let us provide an input prompt. In this case, I'm searching for what is database sharding, and click on Ask RAG AI agent button. This would query our knowledge base and try to search for this exact prompt or the nearest matching prompt and return a response back. We can see the response on the left side, and on the right side, we can view the citations. The citations could come from various documents, more than one or multiple documents, and also it will have link to those PDF or text files. We will generate an audio for the given response. We can also choose various voice options. I've chosen the default unabilized voice. This will leverage Oracle Speech AI, that is text-to-speech conversion.
Database sharding is a technique used in distributed databases to improve scalability, performance, and availability by horizontally partitioning a large database into smaller independent pieces called shards. Each shard is a self-contained database that contains a subset of the overall data.
We can also click on AI translation service by selecting a target language to translate the default text content from English to any other language. For example, we can see here Chinese or German language translation. Now click on the book link. This will open the PDF that is responsible for creating the response to search query as well as the citations. Hit a back button. Let us try one more search. Who is Diwan Purnaya? Click on Ask RAG AI agent. Since we have already trained our RAG AI agent with information related to Diwan Purnaya, we get this information. Click on the PDF and we can view the PDF document. Let us now search for something different, what we have not trained. For example, what is Oracle Web Center? This would return a result. This would, in fact, not return a result with a message that no document is found for the given query. And what we have done in our background code is it would connect to Oracle Generative AI, which in turn connects to large language models such as Cohere or Metallama and gets the result back. But then how do we train our RAG AI agent to handle this query? So let us start by creating a PDF about Oracle Web Center and upload it to our knowledge base. The document would sit in OCI object storage that we can view on the right side of the application. This would also trigger a data ingestion job. Initially, the status will be accepted. After a couple of seconds, it would be in progress, and eventually it will be succeeded. So we need to refresh this periodically to check the status of data ingestion job. We can also use scheduler to make this periodical check of the job status. Now, when we next time search for the same query, that is what is Oracle Web Center, we would get a better answer because our AI agent has been trained on this document. We can also view this Oracle Web Center related PDF. We can also create knowledge. For example, what is Oracle JSON relational duality views? We can query this on Metallama or Cohere large language models, like the one that you're seeing here. Once the LLM result is available, we can save this data in the database, edit the data, add more documents if required, and then this saved data in the form of a database document can be converted into a knowledge base by uploading it into repository. Like here you are seeing it, we are saving it into database table, and we can edit this document. Once our editing is done, we can upload this document to knowledge repository. Once it is uploaded to knowledge repository, the same process will continue. That is, the data ingestion job would get triggered, and then initially it will be in accepted status and then in progress, and eventually it will be succeeded. Once it is successful, we can query on new terminologies related to this document that has been uploaded. Wikipedia can be an excellent source of information. We can use Wikipedia REST APIs to connect with it and get data from Wiki. For example, here you're seeing what is advanced data compression, and we have set of results coming from Wiki, and this document itself can be made as a knowledge base. There are several other ways to create knowledge. For example, I'm uploading an image of pomegranate. And my input prompt is, what are the nutrition facts, calories, and health benefits of this image? Like on the right side, you can see the details on nutrition facts and also health benefits and also the image that has been uploaded. This itself can be a knowledge. That is, you're uploading an image and extracting the content based on that particular image. Now we can upload this image to our knowledge base. Once the same process of data ingestion job completes, we can search for what are the benefits of eating pomegranate, and you can see the response back from the RAG AI agent. We can click on that image and see more details on this particular image. GraphRag is an advanced form of retrieval augmented generation that utilizes knowledge graphs to enhance performance of large language models. In this example of GraphRag, we are showing various search queries associated with various documents and corresponding document citations. It can also be other way around, the books and documents in the knowledge base associated with authors and citations. Graphical representation makes it easier to understand the connecting edges and vertices of an LLM result. Sometimes we might want to generate a summary of a document. In this case, we will search for who is Mahatma Gandhi. You can see the AI response here. And this also brings up the entire document that is stored in the knowledge base. Click on Generate Summary button, and this would generate a short summary of the entire document. Let us try to understand the architecture here. On the left side, we have knowledge creators who basically contribute knowledge in the form of either a PDF document or a document that is in a HTML format. They could scan through a wiki website or get it from any other website or upload documents through, it could be an image, or they could create content online based on generative AI, or they could also log into OCI Cloud Console and just upload documents there. If you look at the knowledge base, it could be either the documents stored in OCI object storage as different files, or it could also be knowledge that is stored in the Oracle Autonomous Database in different format. In the top center, you see AI services where we are leveraging OCI speech. That is primarily we are using text to speech to convert the text content of the results into a audible speech format. This would help people who have issues with reading or text content. They can always hear the speech output. And also you can see OCI language translation service where we can convert the default English into various other languages such as French, German, simplified Chinese, Portuguese, etc. When there are large documents like PDF files, we might want to generate the summary of those documents. For this, we will use Generate Summary AI service. Now let us look at the green background RAG agent section where we have Oracle Generative AI that could connect with any large language models such as Cohere or MetaLlama and get publicly available information using these LLMs. And in the center, you have GraphRag, where we could graphically represent the search and documents associated. For example, a search on or a search related to a database sharding could be related to a couple of documents. So we can graphically represent the search and the citations or citations and the documents through the RAG graph. AI data ingestion is also a required step because every time you upload a new document, that document needs to be processed so that AI agent can provide search results. And on the user interface side, you see Oracle Apex that is connecting to all the services through REST APIs. And on open source version, we have LangChain and Streamlit application that could do the same thing. And in terms of AI models, we are demonstrating this with Cohere and MetaLlama Instruct model, but then we can also use or connect to any other LLM that is available. And Wikipedia is used as a source of free knowledge encyclopedia to get or generate content. On the right side, people who can be knowledge consumers or who could be knowledge creators of the application.